Hello dear students, welcome in our video lecture of redox reaction. This is our sixth video on redox reaction. In our previous video, we were discussing about the nomenclature or not nomenclature but the calculation of oxidation state of a different element in some special. Now in this video, also we are going to learn about the same topic, oxidation number, to find out the oxidation number of a particular element in any compound and the system of nomenclature of compound by using oxidation state, that is known as Stokes notation method. Okay, so let us start. Take your note and pen with you and let us begin. The first compound is, suppose if somebody says first of all we are going to see some 2 or 3 special compounds. Again, the first compound for today is CrO5. This is chromium pentoxide. Now, if we want to find the oxidation state of chromium in this compound, then here the oxygen which are given, that is total 5 oxygen are there. All the oxygens are not having same oxidation state, and that can be decided by the structure of this compound. So we first of all we have to draw the structure of this compound, and what will be the structure of any compound that you will learn in a new chapter which is known as chemical bonding and molecular structure in our syllabus. That chapter we will learn after some time, and after learning that chapter and those concepts, you will be able to draw the structure of any molecule. Okay, so now the structure of CrO5 is Cr. There is an oxygen attached with double bond, and there are 4 oxygens which are attached with single bond, and these oxygens are attached with each other. So this is the structure of CrO5. Now, one new thing. If in any structure, if you see O single bond O anywhere, then such bond is known as peroxy linkage. Now you have to remember this thing. If in any structure, if you see O single bond O, that means if 2 oxygens are attached with each other by a single bond, then such linkage is known as peroxy linkage, and the oxygen which are attached in peroxy linkage are having -1 oxidation state. So both oxygen attached in peroxy linkage are having -1 state of oxidation. They are not considered as -2 where they are attached in a single bond or they are in peroxy linkage. So here we have a peroxy linkage. This is our peroxy linkage. And as these oxygens are in peroxy linkage, then the oxidation state of these oxygens are considered as -1. So here 4 oxygens are having oxidation state -2. But this is the simple oxygen, so its oxidation state is -2. Now, by using these data, we can calculate the oxidation state of chromium. But if you do not know the structure, then you will calculate the oxidation state like this. First of all, let's assume that we do not know the structure of CrO5, and we know only the rules which we have already learned in our previous video. So by using those rules, if you find the oxidation state of chromium, then it will go like this. For chromium, let us assume x plus 5 multiplied by -2 is equal to 0. So x minus 10 is equal to 0. So x is equal to plus 10. So according to those rules, in this compound, the oxidation state of chromium will be plus 10. That is wrong. Oxidation state of chromium is not plus 10. It is plus 6. But how? Then the correct method is, after knowing the structure, then if we want to find the oxidation state of chromium in CrO5, so CrO5 is equal to 0, x plus. Here, all 5 oxygens are not having same oxidation state. there are two kind of oxygen. One oxygen is having -2 and 4 oxygen are having -1 oxidation state. So we have to write it like this because here we have two kind of oxygen, 4 plus 1. One oxygen is having -2 oxidation state while 4 oxygens are having -1 oxidation state. This we can write only if we know the structure of it. And you have to remember this structure right now. Okay. Now x -2 -4 is equal to 0. So x -6 is equal to 0. So x will be +6. Now +6 is the correct oxidation state of chromium in Cr. So if you simply count the oxidation state of chromium by this method without knowing the structure, then your answer will be wrong. But after knowing the structure, there are two peroxy linkages. That means there are 4 oxygen which are having oxidation state -2. Therefore, the oxidation state of chromium will be +6. So this is a compound in which the oxidation state of chromium can be calculated after knowing the structure of that. Okay, so pause the video and just write down this what I have written on the board. Okay, now let us move on. Okay. So, second example. If I write H2SO5, H2SO5, this is known as peroxy mono sulfuric acid. This is peroxy monosulfuric acid. It is not sulfuric acid, it is peroxy sulfuric acid. That means there should be at least one peroxy in this structure. Okay, now let us draw this structure first and then after we will find the oxidation state of sulfur. So S double bond O, single bond O, single bond O, and here there is one hydrogen, and here one oxygen, and then one hydrogen. So here also we have a peroxy linkage. So both these oxygens are in -1 oxidation state, and remaining all oxygens are in -2, and this hydrogen is in +1. This is also in +1. Okay, now let us count the oxidation state of sulfur in peroxy monosulfuric acid. So it will go like this: H2SO5 then is equal to 0. So 2 multiplied by +1 for hydrogen plus X for sulfur plus. Now we will not write 5 multiplied by -2. Why? Because all 5 oxygens are not having -2 oxidation state. 3 oxygens are in -2 oxidation state. So 3 multiplied by -2 plus 2 oxygens which are in peroxy linkage. This is our peroxy linkage. Therefore, oxidation state of these 2 oxygens are -1 is equal to 0. Okay, now this is +2 plus X -6 -2 is equal to 0. This +2 and -2 will cancel, so it is X -6 is equal to 0. So X is equal to +6. That means the oxidation state of sulfur in peroxy monosulfuric acid is +6. Now remember one thing. If the word sulfuric acid is present in the name of any compound, then it is clear that the oxidation state of sulfur is always +6. If the name contains the word sulfuric, then definitely oxidation state of sulfur will be +6. Whether it is only normal sulfuric acid, then oxidation state will be +6. whether it is peroxymonosulfuric acid, oxidation state plus 6, and we will see one more example in which the word sulfuric acid will be there. Then definitely the oxidation state of sulfur will be plus 6. That we are going to see after you write the example. The peroxymonosulfuric acid is also known as Kero acid. K-E-R-O-Z acid. Z is silent. So the name is Kero acid. Kero acid. Okay, just write down this. Okay, now let us see third example. The third example is H2S2O7. H2. Now this is your familiar compound. This is oleum or fuming sulfuric acid. O-L-I-U-M, oleum, or you can call it fuming sulfuric acid, or you can also call it disulfuric acid, H2S2O7. This is disulfuric acid. And if we want to find the oxidation state of this sulfur, then also we have to write the structure of this. So first of all, this is the structure of sulfuric acid. You have to remember this structure. As I told you that you will be able to draw such kind of structure after learning the chapter chemical bonding and molecular structure. Now this chapter has to be very important because in many lectures I have indicated the name of this chapter, chemical bonding and molecular structure. Very important chapter for us in standard 11 and 12 to find out the structure of any molecule. Okay, so molecular structure of sulfuric acid H2SO4 is like this, and we are going to use this structure many times. Okay. So first of all, if we want to make H2S2O7, then first let us write the structure of sulfuric acid. This is the structure of sulfuric acid. Now here it is disulfuric acid. So it must have two sulfuric acid molecules. This is the second sulfuric acid. Now when both sulfuric acid molecules are attached with each other, a molecule of water will be lost. So one OH and one H will be lost. So if we subtract H2O from this, then what will happen? This sulfur will attach with this oxygen. In that condition, our structure will be like this. This will be as it is, and this bond of sulfur is now attached with oxygen, and this oxygen is also having sulfur, two oxygen, one oxygen, and one. Now, this is the structure of H2S2O7. H2, S2, and O. 3 plus 3, 6 plus 1. So here, this is the structure of oleum, and if we want to find the oxidation state of sulfur in oleum, then what will we do? Now, if you observe here, all oxygens are normal oxygen. That means they are having -2 oxidation state. There is no peroxy linkage present over here. O single bond O is not present over here. So it is very simple compound. And if we want to find the oxidation state, then the classical method is use H2S2O7 is equal to 0. 2 multiplied by oxidation state of hydrogen, that is +1, plus 2 multiplied by, for sulfur we will put X, plus 7 multiplied by -2, because all oxygens are normal oxygens, no peroxy linkage is present. So this is +2 plus 2x minus 7 2 is 14. So -14 plus 2, that is -12. So 2x minus 12 is equal to 0. That means 2x is equal to plus 12. That is x is equal to plus 12 divided by 2 will give us plus 6. So the oxidation state of each sulfur in disulfuric acid is plus 6. And as I told you before 2 or 3 minutes that if the word sulfuric acid is there, then definitely the oxidation state of sulfur will be plus 6. So here also in oleum, the oxidation state of both this sulfur is plus 6. Peroxymonosulfuric acid, oxidation state of sulfur is plus 6. Disulfuric acid or oleum, oxidation state of sulfur is plus 6. We will see one more example in which the word sulfuric acid will be there. So just pause the video and write down this. Okay, now let us see the fourth example. Fourth example is H2S2O8. The third example was H2S2O7, but here it is H2S2O8. One oxygen is more than the previous. The name of this compound is peroxydisulfuric acid. The second example was peroxymonosulfuric acid, H2SO5. Now this is H2S2O8, peroxydisulfuric acid. So it is perox and it is sulfuric acid. That means oxidation state of sulfur should be plus 6 over here. We will count it. And the other name for this compound is Marshall acid. Peroxydisulfuric acid is also known as Marshall acid. This is the other name or industrial name of this compound. We have to remember that. Okay, now let us draw the structure of this compound. We have to draw two sulfuric acid structure. One S double bond O, S double bond O, OH, again OH. This is one molecule of sulfuric acid, and S double bond O, OH, OH. This is the second molecule of sulfuric acid. Now, as it is peroxy, then there will be O single bond O. So, if we want to make it, then we have to remove these two hydrogen. So, if H2 is removed from these molecules, then we will have S double bond O, OH. This O is now attached with the second O, and the remaining structure is. So now, as you can see here, this is our peroxy linkage. That means both these oxygens are in -1 oxidation state and the other oxygens are in -2. Now let us count the oxidation state. H2S2O8 is equal to 0. So 2 multiplied by 4 hydrogen, oxidation state is +1, plus 2 multiplied by sulfur, let us assume it as X, plus, now all 8 oxygens are not same. 2 are in -1, that means they are attached with peroxy linkage. So 2 oxygens are having oxidation state -1, and 3 plus 3, that means 6 oxygen are in -2. Okay, so it is +2 plus 2x -2 -6 to 12 is equal to 0. So this +2 and -2 will be cancelled. We will have 2x minus 12 is equal to 0. So 2x is equal to +12. In that manner, the value of x will be. So again, as the name contains sulfuric acid, definitely the oxidation state of sulfur must be +6. So these are some special compounds in which peroxy linkage is present. And after knowing the structure, we can easily find the oxidation state of the given. These are specific, so you have to know consider their structure in your mind. Then only you will be able to find the correct oxidation number for such groups. Okay, pause the video and write down these examples. So now let us move forward. Now I am going to teach you a topic named as stop notation. Stop notation is the method to identify the compounds which are having almost the same kind of name but structure or formula. First of all, let us take two examples. If somebody writes MnO, the name will be manganese oxide. Or let us start with the familiar thing. This is your familiar FeO. Now this is known as iron oxide. Iron oxide. And again Fe2O3. This is also iron oxide. So both are iron oxide, but they are having different formula. So it is not possible the same name for two different compounds. It will create confusion. In initial time or in ancient time, the different words for these different ions were not discovered. They are known as iron oxide. But how can we identify both these different iron oxide differently? So the method stop notation was introduced. In this method, you have to calculate the oxidation state of that particular element, and you have to mention the oxidation state of that element in a bracket after writing the name of that. So here, iron, which are into different oxidation state into different compounds. So after writing the word iron, we have to write its oxidation state in a bracket in Roman. Okay, so first of all, let us find the oxidation state of iron in FeO. Now I'm not going to calculate all the time the oxidation state of any. Just calculate it by heart. -2. If it goes to the other side of equal, then it will become +2. So oxidation state of iron is +2 over here. So the name will be iron 2 oxide. This is the name. And here 3 to the 6, that is -6. If it goes to the other side, it will become +6. And this 2 divided by +6. +6 will be divided by 2, so it will give us plus. So here the oxidation state of iron is plus. Now you know very well how to count the oxidation state of an element in a compound. We have learned so many examples. Now you are confident to have the oxidation state of any element. So this iron is in plus. So we have to write here in Roman figures in bracket plus. So this is iron 2 oxide and this is iron 3 oxide. It is as simple as that. Name is very simple. You have to write the name of the metal and not metal. Metal is Fe, iron or ferrum. You can write it ferrum also. But nowadays, both these ions are having different names. Fe+2 is now known as ferrous iron and Fe+3 is now known as ferric iron. So nowadays the name of this compound will be ferrous oxide and for this we will write ferric oxide. So there will be no confusion. Name itself suggests the type of ion. Ferrous +2, ferric +3. But before these names were known, stop notation method was used. So you can call it an outdated method. Stop notation method is now not used so many. Used regularly. It is not used regularly. Sometimes we have to mention the oxidation state of an element. Otherwise, all different ions are having different names. Okay, now let us see one more. CuO and Cu2O. Both are oxide of copper. This is also copper. But the only difference is the oxidation state of both the copper. Here this copper is in +2, but this is in +1. How you will find how the oxidation state of this copper is +2? And you can find it. Now you are able to find. Okay, so name will be copper in Roman 2 oxide. This will be copper 1 oxide. Some more examples. Cr and Cr2 both are chromium oxide. So we will write the oxidation state in Roman figures. In fact, this chromium is in +2 oxidation state. I know very well, I have already calculated. So it is chromium 2 oxide. And this chromium is in +3 oxidation. 3 to the 6 divided by 2. So each chromium is in +3, so it is chromium 3. So these are some examples which are written in Stokes notation method. Stokes notation method means if we write the name of any compound, then we have to mention the oxidation state of metal or an element after the name of that element in bracket in Roman figure. So one can identify which kind of oxidation state of that element in that compound. Let us see some more examples, then you will write it. MnO. Now let me give you this in your homework. This is your homework. You have to write the name of this compound. Manganese and oxygen. Manganese and oxygen. All you have to do is to count the oxidation state of manganese. Just indicate the oxidation state in Roman figure after writing the word manganese. As simple as that. Again, KMnO4, K2MnO4. Now, let me tell you one more. It is very important to name any molecule. If you see only two kind of elements in a compound, now I am telling very important rule in front of you. You have to write it in your notebook. If a compound is having only two kind of elements, then if you want to name that compound, then name will be like this. Name of first element as it is, but after writing the name of second element, suffix "ide" should be attached to it. Again, if a compound is having only two elements, then name of first element will be as it is, and the name of second element will have the suffix "ide." Let's check it out. Only two elements, iron and oxygen. Name of first element will be as it is, iron. After writing the name of second element, we have to attach a suffix "ide." So it is oxide. Copper as it is, oxide. Chromium, oxide. If I write NaCl, what will be the name? Name of first element will be as it is, sodium. But after writing the name of second element, you have to attach "ide." So it is chloride. Sodium and chlorine are attached with each other. They are two elements. So name of first element will be as it is. But after writing the name of second element, we will attach suffix "ide." So it is sodium chloride. Now give me the name of this compound. Aln. By using this rule, you can write the name of this compound. It is very simple. Name of first element as it is, aluminium. But after the name of second element, you have to add the suffix I. So what will be the suffix for this? It is nitride. Ide. I sounds clearly ide. Aluminium nitride. It is not nitrite or nitrate. Don't confuse in those kind of names. They are different compounds. We will learn about aluminium nitride. If there are only two kind of elements, then name of first element will be as it is. But after writing the name of second element, you have to add the suffix ide. But if there are three elements, and the last element is oxygen, then there is also a rule to give the name of such kind of compound. Now, just write down that rule also. The rule says, if there are three elements and the last element is oxygen, then if you want to give the name of that compound, the name of first element will be as it is, but after writing the name of second element, you have to add the suffix ate. This is also familiar to you. CaCO3. Now, every student is familiar to this compound. This is calcium carbonate or Na2CO3. This is sodium carbonate. Now, just observe the name which I have spoken right now. Calcium carbonate. Name of first element as it is. But after the name of second element, we have attached ate as suffix. Calcium carbonate. So the name is calcium carbonate. Very simple. Okay, there are three elements: sodium, carbon, and oxygen. So name of first element will be as it is, sodium. But after the name of second element, we will attach ate. So it is sodium carbonate. Na3PO4. Again, three element. The name of first element will be sodium, but after the name of second element, we will attach ate. So it is sodium phosphate. Sodium phosphate will be the name of this compound. Same manner, you will give the name of this compound. Again, three elements. Last is oxygen. So name of first element will be as it is, but after writing the name of second element, you attach ate as a suffix, and after that, in bracket, you will mention the oxidation state of manganese. So these are for your homework, and that's all for today's video. In our next video, we will learn about the different kind of redox reactions. So if you like the video, press the like button, and if you have not subscribed yet, then please subscribe our channel, watch our video. These videos are open for all students who are learning in 11 or 12 science. They can watch this video anytime. Okay, so it is for you. So till we meet next time. Very nice.